So today we are doing the next chapter. I am on page 404. This is 5.1 angles in standard position in quadrant 1. Okay. So first things first, I wanted to make sure that you have a calculator, a scientific calculator with you. And please make sure it is in degree mode. There are three modes for your calculator: degree, um, radiant, radians, and gradient. So you have done trig in Math 10, so we're doing more of that today, and we're going to be using the sine, cosine, and tangent functions. So just make sure that your calculator is in degree mode to make to enable us to get the right values. Otherwise, it will sort of give you values that would be confusing. Okay, let's begin. Air traffic controllers use radar to track aircraft. A tracking ray rotates about the center of the radar display and shows a blip as it identifies an aircraft's position. What it's saying is that um, air traffic controllers, as they try to figure out where an aircraft is, they look at the radar, and then on the radar display, an aircraft is not shown as a plane. It appears as a blip. So as it moves, it will tell the um, air traffic controllers the distance and the direction of the aircraft. So one particular aircraft, A, is 100 kilometers due east and 50 kilometers due north of a radar antenna R. Now, if you don't know what due east means, which is this one, what it means is that your um, different northeast um, or south directions would be like this. Okay, so um, since it says it is 100 kilometers due east from the radar and from the antenna, and then 50 kilometers due north of, so it already shows you in the picture what they mean, which is to be 100 kilometers, this one, east, and then 50 kilometers up. Okay. To the nearest kilometer, what is the distance between the aircraft and the radar antenna? Now, I think you could see a right triangle here. Okay. And the right triangle is over there. Okay. And there is your right angle. So, how do you find this? You do Pythagoras. Okay. So let's call this distance d. Okay. If that distance is d, therefore d squared is equal to 100 squared plus 50 squared. Okay, because the Pythagoras is given by a squared plus b squared equals c squared. So let's continue. D squared is equal to, what is this? 1, 1, 2, 1, 2. So that's 10,000 plus, this is 2,500, or 12,500 if I'm correct. Okay. So to find d, that would be the square root of 12,500 and to the nearest kilometer. Okay, so if we get this, this will be about, okay, I put in a dot because that means it's about, all right, 111.8. So the answer to this one, to the nearest kilometer, what's the distance between the aircraft and the radar antenna? It is about 112 kilometers. Okay. Now, it also asks you, what is the angle between the tracking ray to the aircraft and due east? All right. What is that angle? Okay. So if you're wondering, okay, which one are we talking about? Okay, so the tracking ray is this one right here, right? Okay. So the question is, um, which one is due east? Due east is this one. So which is the angle that we're looking for? It's this one. From the horizontal to that sort of hypotenuse of the right triangle. Okay. So to do that, if we call this angle R, this one here, all right, Why is it angle R? Because R is over here. Okay, so we're looking for that angle that is shown by the red curve. All right, now tangent R in this case will be, okay, so tangent R will be opposite over adjacent, right? Adjacent. And if we are going to be putting in the values, the opposite side to this is 50. And the adjacent side is this one, which is 100, which gives us 0.5 or 1 half. Therefore, to be able to do that, what it is saying is the tangent of R is equal to 0.5. Now, guys, remember, what we are looking for is the angle between the tracking ray. This value here is the tangent ratio. That is not the angle. To get the angle, if you remember math 10, that would be to do the tangent inverse of 0.5. So once again, I need you to make sure that you can recall how to do all of these using your calculator. And if we are doing this correctly, I also did it in my calculator a while ago. It is about 26.6 degrees. And it says, um, well, it didn't really say that it should be to the nearest degree, but going by the first question, it says to the nearest kilometer. So it is about 27 degrees. All right. R, or angle R, is about 27 degrees. Okay. So what I'd like you to do is, if it seems to be unclear to you, I would strongly suggest that you stop this video and then rewind and then watch it again. Okay? All right, moving forward. So construct your understanding. Write an expression for R in terms of x and y, the value of theta in terms of x and y, the x-coordinate of p in terms of r and theta, and the y-coordinate of p in terms of r and theta. Okay, so first things first, we need to write an expression for r. R is the hypotenuse, this one. So we're looking for a an expression for the length of r. Now, you can see a right triangle. Therefore, what I can use here would be, if I'm going to redraw here, okay, this is your r, this is your y, this is your x. That means I will have to find my r, x squared. Oh, let's put it the other way. Let's put r squared first. R squared equals x squared plus y squared. And to find r will be the square root of x squared plus y squared. Now, if you're thinking, why is it not plus or minus? Because we are looking at r as a hypotenuse, so it has to be a positive number, no negative. Okay? Now, for the value of theta in terms of x and y, we are looking at this theta. Okay? So, what would that be? We can use the tangent ratio. Okay? So, tangent of theta, or in this case, this is your theta. Tangent theta is equal to opposite over adjacent, which means it's y over x. Or to isolate theta, that would be tangent inverse of y over x. Okay? So we're good with that. What about the x-coordinate of p in terms of r and theta? Okay, so let's try to figure that out. The x-coordinate of p, and p is over here. So we're looking at the x-coordinate, which is just that one. Okay. What would be the x value or the x-coordinate? So let's try to think about what we can get here. What trig ratios can we use? Okay. So I think to be able to give me that x value, let's try to recall um, some of the other trig ratios that we did. Now, guys, that x value, this one here, that x value will be given by this length, isn't it? So really, if you think about it, it will be the cosine ratio that we can probably use. Now, cosine of theta is equal to x over r because it's um, opposite. Oh, it's adjacent over hypotenuse. Okay, so once again, it is adjacent over hypotenuse. So if I'm going to putting in the values here, it would be x over r. Okay. Now, if I want to isolate x, look at this. Cosine theta equals x over r. So multiply both sides by r. Now I have x is equal to r cosine theta. Okay. Now, for the y coordinate, it's pretty much the same. So it's going to be, um, instead of cosine though, it would be sine theta, which would be equal to opposite over hypotenuse, which is equal to, in that right triangle that we have, okay, like this. This is theta, this is y, this is x, this is r. So the opposite is y over r. And if we want to isolate y, since we have sine theta equals y over r, multiply both sides by r, we have y equals r sine theta. So once again, if it's something that is not so clear to you, I strongly suggest that you stop the video and rewind and watch it again. Okay? Now, moving on. The coordinates of a point P on the coordinate plane can be described by the distance r from the origin and the angle theta that OP, all right, OP would be this line segment that it makes with the positive x-axis when the angle theta between 0 and 360 is measured counterclockwise. So when we measure angles, positive angles are measured counterclockwise. In pre-calc 12, we are doing angles which are negative, but for now, let us just concentrate on what pre-calc 11 is doing, which is positive angles, which is going counterclockwise. When an angle is measured counterclockwise from the positive x-axis, the positive x-axis is this one, the horizontal one. Then the angle is said to be in standard position, all right? Meaning that, other terms, the ray OP, this one is the terminal arm of the angle, and the point P is a terminal point. So what it's saying is, so if your angle is this one, right here, right? This is your terminal arm. This is your initial arm, okay? Say it again. This is your terminal arm. This is your initial arm, okay? So let's see. Let's look at how we solve problems related to this. So the point 34 is on the terminal arm of an angle in standard position. Determine the distance r from the origin to P. Determine the primary trig ratios of theta. Determine the measure of theta to the nearest degree. Okay, so let's do it one at a time. Let's do A. So I think at the beginning we can draw a coordinate grid, and let's figure out where point P is. 3, 4. 1, 2, 3. 1, 2, 3, 4. It's just a quick sketch, all right? So that probably is point P. Okay, point P. There you go. Now, determine the distance r from the origin to P. So we are trying to figure out this distance here, okay? All right, so what is that distance r? Now you have to understand that P, or this r, makes a right triangle with this one, okay? Wherein this side is 4, this side is 3. Okay, x, y. Now, the distance r would be given by the Pythagoras, and it would be r squared equals 3 squared plus 4 squared, and that would be 9 plus 16. That would be 25. Therefore, r squared is 25, which tells us that r is equal to the square root of 25, which is 5. It is not plus or minus because r is a distance. Okay? All right. So next we do, so this is a, next we do the primary trig ratios. Okay? When you talk about the primary trig ratios, it means it's the three trig ratios that you learned in Math 10, which is sine theta, cosine theta, tangent theta. Those are the three primary trig ratios. Okay, so the theta here is this one. Okay, so I'll use a different color too. Okay, there is your theta. The angle that the terminal arm R makes with the um, x-axis. Okay, all right. So let's do them one at a time. Sine theta is equal to opposite over hypotenuse, which is 4 over 5. Cosine theta will be given by adjacent over hypotenuse, which is 3 over 5, while the tangent will be given by opposite over adjacent, which is 4 over 3. Okay, that's pretty easy. So to find the measure of angle theta to the nearest degree, all right, you can use any of these three. Okay, what I'm saying is this one has theta. You can isolate this by doing theta is equal to sine inverse of 4/5, or you can use this where theta would be equal to cosine inverse of 3/5, or you can use this. Okay, I'll just use tangent then. Okay, since I know that tangent theta is equal to 4/3, therefore theta is equal to tangent inverse of 4/3. Okay, and using our calculator, I already did it a while ago. It gives me 53.13 something, okay, degrees, and it says what is the, it says to the nearest degree, so theta would be about 53 degrees. Okay, so what is the key takeaway here? What you need to figure out is to first, when you're solving problems like this, I strongly suggest draw a coordinate grid and plot the point like what I did here. Okay, I tried to figure out, okay, how does it look like? And then from that point, draw a line segment that connects it to the origin. You will see that you will be able to create a right triangle, and from then on, you can use Pythagoras to find the hypotenuse. You can um, you will be using that right triangle to give you the values for the three primary trig ratios, sine theta, cosine theta, tangent theta. And then you will be using one of those trig ratios to be able to get the value of theta. Okay. Um, sort of an extending your understanding is, now that we have found that theta is equal to 53 degrees, why don't you try the other two? See if you can use this instead and see if theta will also become 53 degrees, all right? Or this one. And of course, you're supposed to get the same value. Okay, next one. So trig is essential to navigation. A direction can be described by relating it to two of the compass points, north, south, west, east. For example, a heading of west 30 degrees south tells you that if you were to go west, okay, because W comes first, as you go west, you will go 30 degrees to the south. All right. So it's like if you're starting here, all right, so I'm going to be using different color. If you're starting here, you will go west, and then from there, you will go 30 degrees to the south, all right? You will see an angle that would be 30 degrees going to the south. There you go, all right? So the same idea with this one, if it was 40 degrees west, 40 degrees north, you will go 4 west, and then you go up 40 degrees, okay? Now be careful, you're always talking about a measurement of an angle that is starting from the horizontal axis, because in this case it's always talking about west or east. Okay. All right. So let's do the check understanding. A forest ranger sees smoke rising from a point that lies in the direction east 40 degrees north. She estimates that the distance from the ranger station is about 30 kilometers. The firefighters at the ranger station have to travel east, then north to get to the fire, to the nearest kilometer. How far should the firefighters travel in each direction? Okay, so draw a diagram. Okay, so let's come up with a diagram here. We go east. Okay, so it's like go this way, and then you go north 40 degrees. Okay, so there is your 40 degrees north. Okay, now, and then what? So the O represents the ranger station. So I'll put an O here. And then what? So let's put a point P to represent where the fire is, right here. Okay? Now, she estimates that the distance from the ranger station is about 30 kilometers. Okay, now, so what this is saying is that the um, the fire is 30 kilometers away from the ranger station. So this one is 30. Okay. So the question is, um, how far do the firefighters have to travel east and then north to get to the fire? So we need to figure out what this is. Okay. What this is and what this is. Okay. So in this case, since this is your x and there's your y, okay. So this is, remember, this is east, this is north, this is west, this is south. So to figure out how far they have to go to the east, okay, so we need to be able to think about this x value. What is this going to be? And that x will be given by, okay, we already have seen it before. X is equal to r cosine theta, right? And that will be 30 times cosine of 40 degrees. Once again, make sure that your calculator is in the right mode. If you do this properly, it would be about 22.98. Okay. The nearest kilometer, that would be about 23 kilometers. Okay. About 23 kilometers that they have to travel um, to the east. Okay. To the east, to eastward. All right. To the east. And then what? We're also supposed to figure out how far they're supposed to travel going north or due north. So it's this one, this time that I need to find out. Okay. All right. So this one talks about this. Okay. Well, this one talks about this. Okay. So now I'm doing the y. So to find the y, we already saw it earlier. It's r sine theta. And again, let's just look at the values. What is r? r is 30. What is theta? 40. And if you do that correctly using your calculator, okay, that would be about 19.28. And the nearest kilometer is about 19 kilometers due north to north. All right, so in summary, the firefighters should travel approximately 23 kilometers east, then approximately 19 kilometers north. All right, so once again, if you have a question or if you're unclear, please stop and then rewind and take a look again. So suppose a point PXY lies 1 unit from the origin. All right. So you have a circle. This one is called a unit circle, by the way. And a unit circle is defined as that circle that has its center at the origin. The origin is this one, which has coordinates 0, 0, and the unit circle has a radius of 1. Okay? What this is saying, as the terminal arm OP rotates, P traces a circle. So what it's saying is at the beginning, OP was over here, okay? And then it rotated, it went this way, and then at some point, this is where it is, and then at some point, it will be here, and then here, and so on and so forth. And by the time it goes back to where it started, it would have traced a circle. So the Pythagoras can be used to relate the radius of the circle and the coordinates of P, okay? So using Pythagoras, as you can see, the this one is point P. If you want to find um, a relationship there, it will be x squared plus y squared equals 1 squared, which is this one. Okay? Now, what is that? That is an equation of the unit circle. All right? Once again, the unit circle is a circle that has radius 1, its center at the origin, and has the equation x squared plus y squared equals 1. Okay? So, any questions about that? Now, more on this on the next section, but for now, you may want to take a look at the lower part of this page. This is page 408, wherein there's some discussion about how to get certain values of certain angles. I leave that to you to do because in the next section, we're going to do more of that. All right. So I'll end this section for now, and then I'll make another video for 5.2. Okay. Thanks. I hope you enjoyed this.